Today we are going to present about flow network in case study based, an important concept in algorithm design and real world optimization. A flow network is a direct graph where each edge has a capacity. Flow move from a source node to a sink node. The goal is to find the maximum flow that can pass through the network without exceeding capacity limits. Further, we'll explain. Vinesh.
There are two important rules of the capacity constraint. Flow cannot be exceeded edge capacity. Flow conservation. Incoming flow equal outgoing flow from intermediate units. Flow networks are widely used in water distribution system, traffic management, computer networks, supply chain system. This presentation we will explain how flow networks work and how they can be applied in real life systems.
Now, let's understand the basic components of a flow network. Key elements: source, sink, edges, capacity. Source, starting point of flow. Sink, ending point of flow. Edges represent connections between nodes, and capacity, maximum flow allowed through an edge. Flow value, the amount of flow passing through the network. Flow must be non-negative. Flow cannot exceed capacity. Total flow entering a node must equal flow leaving it. These basic concepts form the foundation for applying algorithms to compute maximum flow. Now let's see how a flow network is represented. A flow network is drawn as a directed graph. Nodes represent points in the system. Edges represent paths or connection. Each edge is labeled with capacity. Source connects to intermediate nodes. Intermediate nodes connects to sink. We assign capacities to each edge based on system limits. This representation helps us visualize the flow, identify bottlenecks, apply algorithm easily. By converting real-world systems into graph, complex systems become easier to analyze and optimize.
Algorithm explanation. To find the maximum flow, we use the Ford-Fulkerson algorithm working principle. So we repeatedly find paths from a source to sink and send flow through them. So steps start with zero flow, find the path from a source to sink, find the minimum capacity in the path, send flow equal to the minimum value, update the remaining capacities, repeat until no path exists. Key terms: augmentation path, residual graph. So augmentation path, a path where additional flow can be sent. A residual graph shows the remaining capacity after each step. This method ensures that we gradually increases the total flow until the maximum is reached. Time complexity is O of V into max flow. This algorithm is simple and effective for solving a maximum flow problems.
Applications: water supply system, efficient distribution, traffic system, reducing congestion. Computer networks, data routing, logistics, movements of good, goods. Advantages: efficient use of resources, better planning and optimization, helps in decision making.
Okay, guys, let's see the question section. The first question is, what is a flow network? Can anyone see?
The flow network is directed gap by each edge has a capacity and flows move from the source node to the sink node. We aim to find the maximum possible flow without exceeding our capacities.
So we may move to the next question. What is maximum flow?
Maximum flow is the largest amount of flow that can go from the source to the sink while satisfying all constraints.
The next question, what are source and sink?
Source is the starting point of flow. Sink is the ending point where flow is collected.
Good. The next question is, what is the capacity of flow network?
Capacity is the maximum limit. Follow the chip flow that an edge can carry.
So next question, what is flow conservation?
For every node except source and sinks, incoming flow equal outgoing.
Thank you. Networks, a powerful mathematical model to represent system where something flow such as water, traffic or data. By using algorithm like Ford-Fulkerson, we can systematically calculate the maximum possible flow in a network while respecting all constraints. Thus, not only improve efficiency but also help in making better decision in real world system. Network are therefore widely used in engineering, computer science and operations research, making them a fundamental concept in both academics and industry. Overall, understanding flow network help us design smarter, more efficient system for the future. Thank you all.